Welcome back to laws of motion. We were discussing linear momentum. It's a product of mass and velocity. A body at rest has got zero momentum and a body in uniform motion has got a constant momentum. My question was, who will change or what will change linear momentum of a body? Answer: linear momentum of a body can be changed by an external unbalanced force. Only when an external unbalanced force acting on a body, the momentum will change. So, who will change momentum of a body? It is by force. So, momentum is changed. Linear momentum can be changed by a force. What kind of a force? It should be external and should be an unbalanced one. So, if I have a body here, it is at rest, but if I apply a force on it, an unbalanced force, if I apply two balanced forces, its momentum will not change, but if I apply a single force, its momentum can be changed. So, whenever force is acting on a body, it changes the momentum of a body. If there is no force acting, what will happen? Momentum will not change. That means either it will be zero or it will be uniform. So, that is a role of force in motion, linear momentum. Okay. Now, out of different kind of changes, sometimes we use a term, okay, it's here, we use a term impulse. Okay. We use a term impulse. Impulse stands for change in linear momentum. I should learn to write linear momentum. Okay. See, understand that this is linear impulse which changes linear momentum. There is angular impulse which will change angular momentum. Okay. So, impulse is change in momentum. But this is generally applicable when the change in momentum is fast. Sudden changes in linear momentum is called impulse. Fine. Now, I see another word here, impulsive force. Impulsive force is a large force acting in a short interval. A large force acting on a short interval is called the impulsive force. But understand that this large and short are relative. But normally in our life, a force, like I have a table here, I can keep pushing the table. This is not an impulsive force. But if I hit on the table, that force acts for a short amount of time, it's called an impulsive force. So, whenever I write on the board, all these are impulsive forces, and as a result, momentum may change. That change in momentum is called impulse. So, impulse is change in momentum due to impulsive force. Impulse is change in momentum due to impulsive force. I will explain it. Suppose there is a body of mass m which is initially at rest, initial velocity 0. Then you go and kick it, like it's a football, you kick it. When you kick it, the force will act over a small amount of time. So, there is a impulsive force. The kick is an impulsive force. This impulsive force will create a change in momentum. This will create a change in momentum. Of course, the linear momentum. Now, the change in momentum created due to the impulsive force is called impulse. And what is impulse? I will tell you. What is impulse? In examination, you need to calculate impulse. So, what you need is to calculate change in momentum of the body where the force is applied. I will say like this, that impulse of the body is a change in momentum of the body. The impulse applied by the impulsive force is equal to change in momentum of the body. Who is applying impulse? The impulsive force. And what is impulse equal to? change in momentum of the body. So if you can calculate change in momentum of the body, then you can calculate impulse. So what is impulse and what is impulsive force? Impulse is a change in momentum created by an impulsive force. And what is impulsive force? A force acting for a short interval of time, very short interval of time. Okay. Now further, impulse is generally written as J. J for impulse, but it is a vector. Impulse is J, and that is equal to delta is for change, delta in P. That means impulse equal to change in momentum. Normally, we write this change is calculated as final momentum minus initial momentum. So we write a P final minus Pi. You should know the vector subtraction. Study vector subtraction. You studied that, right? Subtraction of vector is very important in this chapter. So this is how you write J equal to delta P. J is the impulse. What is the direction of direction? What is the direction of impulse? Direction of impulse equal to direction of change in momentum. Direction of impulse equal to direction of change in momentum. And I'll tell you, this will be in the direction of, that's important to know, that is in the direction of the impulsive force. Next class onwards, we will have numericals based on all this. So, direction of the impulsive force is the direction of the change in momentum, is the direction of the impulse. So, J equal to delta P. And what is the dimensional formula? Dimensional formula of impulse is the dimensional formula of momentum, mLT raised to minus 1, because the impulse is change in momentum. And what is SI unit? SI unit is Newton second, or it is also kilogram meter per second. Both can be used. Generally it's Newton second, but it is also kilogram meter per second. So this is about impulse and impulsive force. So everybody apply an impulsive force somewhere. Apply an impulsive force somewhere. You hold a pen tight like this. This is not impulsive force. It's a force. Impulsive force means that should be acting in a short interval of time. Like you beat like this. Impulsive force. If you don't study, I will give you an impulsive force with a cane on your hand. Impulsive force. A wala. Each is an impulsive force. You kick a table, kick a football, that's an impulsive force. That creates a change in momentum. Okay. Fine. So I think that part is clear. Sorry for that. Next one, force time graph. Many a times what we do is that we will draw force time graph. We will take force on the y-axis, time on the x-axis. We can draw a force time graph. This is time, this is force. If I draw a line like this one, it means that there is a constant force. This is a constant force. Now, if I give you a time t1 here, another time t2 here, then see this. Then see this. This area. This area. That area gives change in momentum. So, area of force time graph gives you what? Change in momentum in the given interval. In the interval. In the interval given. Change in momentum in the interval given. Now, see, I am giving you another kind of graph where the force graph is represented like this. That means the force is acting for only for a small interval of time. This interval can be taken as delta t, a very small interval of time. And there is a large force acting for a short interval of time. So this represents an impulsive force. It represents impulsive force. It represents impulsive force, and that area and this area, that area equal to what? That area will be equal to change in momentum, but this change in momentum is due to an impulsive force. What is a change in momentum due to impulsive force is called? It is called impulse. So force time graph can be given in examination. So these are the things that you need to understand. Then the force time graph can be irregular shape. Then we will use integration to calculate it. Okay, I will represent that one also. Now in such cases, if you want to calculate, here it's very easy to calculate area. Suppose this force is F, then this area will be like area of this rectangle F into T2 minus T1. That's why the unit becomes force into time, Newton second. But in such cases, the area is calculated like I'll write the area is the impulse J. This is calculated using the vector integration f dt in that time t1 to t2 in the small interval f dt. It's integration method. So this is not integration, because if it is a identifiable shape like this one, you don't need integration, but here irregular shape means you have to go for integration. Don't worry, when we do questions this will be clear. I just gave you the note. So you need to write down these things in your notebook. It's about impulse. Okay, force time graph. Sometimes things come in front of you like this, impulse momentum theorem. Okay, this is nothing new, you already studied about this. Okay, I told you what is impulse. Impulse is what? Change in momentum, right? Impulse is what? Change in momentum. That's what impulse momentum theorem is. Okay, but it is stated like in a better way. Fine. That is like, you can write like this one. Impulse of a force is equal to, impulse of a force is equal to change in momentum of the body where the force is applied. That's it. Impulse of a force is how much? Is equal to the change in momentum of the body where the force is applied. Or in the reverse way, you can say change in momentum of the body is equal to the impulse applied. If I have an object here and I apply an impulsive force, then the change in momentum of this body is equal to impulse applied. That is another statement. And this one, suppose I have a football, there is a ball here, and I kick it, there is a kick, that is a force. Then I can say impulse of the kick is equal to change in momentum of the ball. Simple. Impulse of the kick equal to change in momentum of the ball. Suppose I kick on the table, then what is the impulse of the applied force? Impulse of the applied force equal to change in momentum of the table where the force is applied. Okay, if somebody punches you on your nose, then what is the impulse momentum theorem? Impulse of the punch is equal to change in momentum of your body, because that is where the force is applied. Is that okay? This impulse momentum theorem. Mathematically, how to write this? Mathematically, we write like a J equal to delta P. J equal to delta P. And I also told you that this is calculated using that integration f dt. It is integration f dt. J equal to delta P equal to f dt. You will study this better after you learn Newton's second law of motion. After that, this idea will be clear. So, if it is asked what is impulse momentum theorem, write whatever I have written just before this and write this equation also. Impulse momentum theorem. Okay. Next one, rate of change in linear momentum. How to find a rate of change in linear momentum? This is important to understand. I don't know how many times I say important. Everything seems important. So people may have this question, is there anything which is not important in the class? Of course, such discussions are not important. Whatever serious are important. Okay. Fine. Now, first point, how to find Oh, no, wait. How to find momentum? First, let us start like this. How to find linear momentum? Linear momentum is calculated like P equal to m into v. How to find change in momentum? Change in momentum is written as delta P, of course P here, equal to, there are many methods. One, you can write like a final momentum minus initial momentum. Okay. Consider if mass is constant. If mass is constant, then delta P is equal to, my point is that how do we change momentum? What are the possibility of changing momentum? See, momentum is a product of mass and velocity, you know this. So when you ask to change momentum, three possibilities are there. What are they? Change momentum means it can be a change in mass. If mass changes, momentum changes. It can be change in velocity. Change in velocity means increase the speed, decrease the speed, direction of motion change. All of them are change in velocity. Otherwise, it can be both. You can do both. Mass and velocity can be changed. But here I am saying mass is constant. If mass is constant, then only velocity can change. So we will say mass will remain constant and velocity will change. We will write final velocity minus initial velocity, or simply m into final velocity minus initial velocity. That is delta P. Sorry. Momentum is this, change in momentum, either this format, and if mass is constant, this format, change in momentum. Fine. Now I will come to rate of change in momentum. Rate of change in momentum in an interval. Rate of change in momentum in an interval is defined as change in momentum divided by time taken, which is delta P by the interval delta t, delta P by delta t, delta P divided by delta t. And what is delta P? It is final momentum minus initial momentum divided by the interval t2 minus t1. Understand that t1 is the instant where you consider the first momentum, t2 is the instant where you consider the second momentum. So this can be, this is what we call, this is delta P by delta t. And if the interval become extremely small, if the interval becomes, this is not this is something that you should know, very small. If it becomes very small, then I think I'll continue that here, this side. Then this is written as dP by dt. It is written as dP by dt. Why? Because you will say delta t tends to 0. I'll write like this one. It will be written like a limit. You studied this, I hope. Limit delta t tends to 0. Delta t tends to 0. Delta P by delta t equal to, what is delta P by delta t? Delta P by delta t is the change in momentum over a large period, and this is dP by dt. Now what is the difference between that delta P by delta t and this thing? Okay, let me clear this thing. Okay, I'll clearly tell you what it is. If you want average rate of change in momentum, then we calculate delta P by delta t. Average. Okay, but if you want what? I hope you can understand this one. If you want instantaneous rate of change in momentum, then you find dp by dt. That's the only difference. So title is rate of change of linear momentum. There are two calculations. One is average calculation, another is the instantaneous calculation. What is the difference? There is no difference actually. Delta p by delta t. If you calculate this for a very small period, then that is called instantaneous. Instantaneous and average is the only difference. One is for a large period, another is for a very short interval. That's it. Short interval means you use differentiation. Large interval means you just take the ratio. Okay. So, children, we studied about momentum, change in momentum, rate of change in linear momentum. Now we are going to study the ever famous Newton's second law of motion. And what does that state? It states that the rate of change in momentum of a body, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. Statement: the rate of change of momentum of a body is directly proportional to the applied force acting, and the change in momentum will take place in the direction of the force. This is a statement of second law of motion, very important to study, because from this we will derive certain relations. Okay. Now let us study what it is. Okay. Assume that there is a body of mass m. Okay. Assume that you are applying a force on it. Then the body's momentum will change. And they say the rate of change of momentum is directly proportional to the applied force. Assume that this force is acting for that particular instant. Then I can write at that instant F is proportional to, how to write a rate of change of momentum for an instant? It is written as dp by dt. So this statement is converted into a proportionality, F proportion to dp by dt. Naturally, we can write this as an equation. What is the equation? F is equal to, put a constant here, that is sufficient, dp by dt. But by properly defining Newton, the unit of force, by properly defining unit of force, K is taken as 1, K is equal to 1. By properly taking K is equal to 1, then we write this equation as F is equal to dp by dt. I should explain why K is equal to 1. Why K is equal to 1? This is by properly defining unit of force. Meaning, the unit of force is defined such that K is equal to 1. So, no worries. So, no constant to be memorized. So, this is the equation for force. Okay. So, what to say? If you want to write this one, you should write like this one. You should write like this thing. Consider a body of mass m acted on by a force F from second law of motion. From second law of motion, write this part, F proportional to dp by dt, F is equal to K dp by dt. Then you should write here, then this thing should come. By properly defining unit of force, or we'll write that in a simpler way, okay? Unit of force is defined such that K equal to 1. Therefore, F is equal to dP by dt. So this gives you the derivation of the ever famous equation F is equal to dP by dt. Fine. Now let us continue. That is what we have here. Okay, equation of force derivation. So first part I did, and I hope it's clear. The first part I did. The first part I reached here. What did I reach? I reached F is equal to dP by dt. F equal to dP by dt. But we know, but momentum P equal to mv. Momentum P equal to mv. So what is F equal to? F is equal to F is equal to d by dt. This is derivation, differentiation of momentum mv. In mathematics, you should have studied that if you have a product uv, d by dx of uv equal to u into dv by dx plus v into du by dx. You studied this. Apply that here. What is this equal to now? F is equal to m into dv by dt plus v into dm by dt. B into dm by dt. Okay. Now F is equal to, see, my class became more mathematical. I want to do that experimental physics class, okay, but this is for mathematical. What is dv by dt? Rate of change of velocity with the time is called acceleration. So that will be written as F is equal to m into a plus this is written as dm by dt itself. So this is the force equation. This is the equation of force, and this is the derivation. Fine. But if mass is constant, okay. Whenever we see dy by dx, what is the meaning of dy by dx? This is about a change in y by change in x. That is the meaning of dy by dx. Basically, this is the meaning. So here, what is the meaning of dv by dt? Change in velocity by change in time. That's my acceleration. What is dm by dt? Change in mass by change in time. Change in mass. So change in mass, but here mass is constant. If mass is constant, then we can say change in mass equal to 0. If mass is constant, change in mass equal to 0. So this dm will become 0. Okay. Therefore, dm by dt will become 0. Time is changing, but mass is not changing. So 0 by something will give you 0. So apply that here. So the second part will disappear. You will get F is equal to m into a. F is equal to m into a. Now, you studied this F is equal to ma back in 9th standard, or maybe before that. Remember the teacher who taught you this equation F is equal to ma. Okay, if you have their number, call them. എന്നിട്ട് പറയണം ടീച്ചർ ഈ ചതി ഞങ്ങളോട് വേണ്ടായിരുന്നു, because that teacher taught you only F is equal to ma, but the actual equation is F equal to ma plus v into dm by dt. This is only part of that equation. This part was concealed. This was not taught. This was not expressed. That is cheating. That teacher cheated. This is the full equation. This is only a part of the equation. Okay. Why? Because in the lower grades, up to just before 11th standard, we will have only constant mass systems. Wherever mass is constant, so only this was sufficient. So the teacher did not cheat you. They actually taught you a right thing, because in all those cases mass was constant, so F is equal to ma is correct. But here, this year, there can be sections where mass can be different. So we will have to study it in this format. This is only a special case. Okay, F equal to ma is only a part of that one. Okay, so what is F? Force. What is m? Mass. What is a? Acceleration. Force equal to mass into acceleration. Applicable only when mass is constant. Okay, so this is the second law is important. You can be asked state the second law of motion and derive the equation of force. Then this is the whole thing that you need to do. First derivation in this class. Hope you liked it. Practice it. Okay. Now we have that force equation F is equal to ma. Okay. So here for the time being, we will write the equation as F is equal to okay. Let me write like this: F equal to dP by dt. F equal to dP by dt. Now we are going to discuss this in the component form and variety of forms. Component form. We know force will have you studied vectors. A vector can have 3 components. Okay. So this force can be written as Fx in the I direction plus Fy in the j direction plus Fz in the k direction. That is this force. The 3 components, the x, y and z components. Momentum also can have 3 components. So this will be like a d by dt of px in the I direction plus py in the j direction plus pz in the k direction. So this can be written like a d by dt of pxi plus d by dt of pyj plus d by dt of pzk. So this is a whole equation in the component form. Now if I relate, see, you can see that there is an I term here and there is an I term here. So I can write it like this. I can write like this, and Fxi is equal to dPxi by dt. Since both are representing the same direction, magnitude wise I can write Fx equal to dPx by dt. Similarly, Fy equal to dpy by dt and Fz equal to dpz by dt. Okay, I can write like this. I can write like this one. But what does it mean? Very important, very important. Okay. It means that x component of force. Dekho, 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 dekho. F component of the force will change which component of momentum? X component of force changes x component of momentum. Aha, that's great. X component of the force will change x component of the momentum, y component of the force will change the y component of the momentum, z component will change the z component of the momentum. So, if x component is absent, x component of momentum will not change. If y component is absent, the y component of momentum will not change. And if z component of momentum remains constant, that means z component of force is 0. Component relation. Okay. Write down, study. See, we have been doing this for the 3 classes, including today's class. I have been giving you a lot of ideas, the basic ideas. And next class onwards, we will do numericals on this. So you will have to use all this. Fine. So that part is done. Now everywhere I was using instantaneous force. That's another point. Instantaneous force. Because when I write dP by dt is the instantaneous change in momentum. So it's all about instantaneous forces. Okay. Now many a times we will use average force concept. Okay. Many times we will use average force constant. If you want average force, then we write F is equal to delta P by delta T. Then we have F in the x direction plus F in the y direction plus Fz in the k direction equal to delta Px delta T in the I direction plus delta Py by delta t in the j direction plus delta pz by delta t in the k direction. Again components are equal. So what is the average force in the x direction? That is the average change in momentum in the x direction. Average force in the y direction is average change in the momentum in the y direction and so on. Same relation but in the average form. Instead of d, you write delta, that's only change. Fine. If motion is in straight line for one dimensional motion, I think I should have some patience to write for motion in straight line. For motion in straight line, you don't have to use iz and all. You just have to use only one component. You will write like f is equal to delta p by delta t, which is m into v minus u by t. M into v minus u by t. Okay, because this is nothing but f is equal to m into a for constant mass. If mass is constant, you can directly use this. Fine. Now, more on this. For constant mass situations, see this, f equal to m into a. Again vector form, fxi plus fyj plus fzk equal to m into ax plus m into axi, m into axi plus m into ayj plus m into azk. Or force in the x direction will change acceleration in the x direction, force in the y direction is m into ay, force in the z direction is m into az, component form. If it is average force, if you want average force, then we write fx equal to m into, what is acceleration in the x direction? Vx minus ux by t. Force in the y direction is m into vy minus uy by t. Force in the z direction is m into vz minus uz. My v and u sometimes look the same. M into vz minus uz by t. In projectile motion, you studied that the horizontal velocity will not change. Reason, horizontally there was no force. Horizontal velocity, initial and final were equal, there is no horizontal force. Only vertical will change. There is Fy in projectile motion, Fx is not there in projectile motion. Component form are used there. Okay. One question. A body is thrown vertically upward. A body is thrown vertically upward. Mass is m, initial velocity u. Another body is thrown, velocity u, mass m at an angle 60 degree. What is the linear momentum at the highest point? What is the linear momentum at the highest point in these two cases? Calculate, keep it with you. Next class we will compare. Let's see how many of you have actually understood this. Next class onwards, we will have a lot of numericals to be done. So keep yourself sharp and updated. Thank you. See you in the next class.